it's becoming a lot more complex. And it is, in fact, there is something which is called the Kessler syndrome, which is a bit of like, panic station situation where a tiny piece of debris is going to create this kind of domino effect of now everything is just going to impact everything else on the orbit, and this orbit is just going to become a huge mess of junk. And also, it's also not enough to, let's say, being fear-mongering and saying, oh my God, we have all these space weather storms and life as we know it in space and on Earth is gonna finish. We have to be prepared for the eventuality in which, there is another storm like this one, and what is happening to my operations, what is happening to my spacecraft. Because when this happens in space, your subsystems on a spacecraft, especially the thermal control solar panels, they are gonna see a degradation of the material itself, which is probably 300x what they would see in their lifetime. What I used to say is space dots detects and attributes hidden threats. These are the ones. So hidden threats, they could come from space weather events, especially radiation, because radiation is one of the main harshest elements that you can face on orbit. On a low Earth orbit, we also have atomic oxygen, which is something that you don't have on other orbits. And atomic oxygen really eats away life and performance from your systems, from the paints or the coatings that you use for thermal control systems. So there are threats which are by default present because of the harsh environment of space. The ones that could mimic space weather, which are the non-kinetic ones. And then there are the kinetic attacks, like laser dazzling, chasing, or actually attacking a satellite.
I was quite shocked I was looking at some of the data on, accidents and things that happen. 90% we don't know why. We can see the impact, but don't know why. Baseline.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human. Make you question everything.
Today, you're going to meet Bianca Cefalo. Bianca's an astronautical engineer who has worked on hypersonic re-entry, satellite systems, and the NASA InSight system, which was a mission that landed on Mars. She's helped lead thermal innovation at Airbus and co-authored research that shows you can cut thermal costs within satellites by 60%. Bianca's now building Space Dots. It's an intelligence layer that helps us finally understand the environment around Earth, where tens of thousands of satellites are now operating. In this episode, we're really going to start at the basics, so you can understand space the way the engineers do.
I usually say that I accidentally fell into space engineering or space science, because what I actually wanted to do was to be a Formula One engineer. And so I grew up with my dad having a business, an automotive business, and I was fascinated by everything. So everything, like how things would work. So I would spend my childhood in the garage with my dad, seeing all these amazing Italian supercars not as they were, beautiful, but from the inside out. So I would see like pieces of Ferraris or Lamborghinis, and I was like, this is amazing. How are these things working together? And I was so fascinated by all of that and Formula One over Sunday lunch with my family that my dad was actually the one saying, probably you should become an engineer. And I was like, what do you mean? It's an engineer too. And then eventually, fast forwarding, I was very fascinated by aerodynamics of supercars, to which I literally Googled, how do I become an expert in aerodynamics? And the result was, you have to become an aerospace engineer. And I was like, no, I'm just going to stay in this. Once I've tasted hypersonic aerodynamics, I'm never going to go back to anything else. And that was really the accidental falling into space science.
2013 came up in my research for this conversation, which it was the film when the movie Gravity with Sandra Bullock was released.
Oh, yes.
Which I watched and still remember those feelings of vertigo and fear and isolation when some of the things were happening in orbit and that, like being stuck in orbit and the danger of things flying around.
Yeah.
So it's state to you is that SpaceX has totally changed the economics of low Earth orbit. And we look at like usable services like Starlink, which are, distributed low-cost satellite systems that are providing, profound services to battlefields and remote worlds that are just connecting people.
Everyone who started a space tech business as a private, outside of the legacy businesses, outside of the agencies, has definitely been inspired by what Elon Musk has done, and is definitely using the rockets to go to space. We launched our first payload to space in January with SpaceX. So I love what even Jeff Bezos, the same. So they have come into the industry and they've shaken up things that were so old-fashioned. And this has inspired so many of us to start something completely new. It's given us possibilities to go to space, and again, at a cost that wasn't really conceivable before. And I also think that you can be inspired by somebody who's come before you and see the wonder and the creativity and the persistence. Because if you think about SpaceX, it took them more than 20 years to become who they are. And I remember watching videos of Elon Musk long before he was who he was. And I remember once he was crying because nobody believed in him and everybody thought that whatever he was doing was never going to work. It's insane to think how much has happened because of that, one person thinking, this is going to happen, I'm going to get it done.
Yeah, I spoke to Patrick Sheehan at ETF as we were talking about, and he made this really interesting statement that, following the data, that over the next 12 years, it'll be cheaper to put a kilogram of payload into low Earth orbit than send it via Royal Mail in the UK. And I questioned that. And then I looked at the data, and actually, if you extrapolate the lines, it does turn out that I think around 2032, it's cheaper to put a kilo into low Earth orbit than send it via Royal Mail. And it made me think, the benefits of low Earth orbit, like microgravity, like a clean vacuum, all of these things that change the way engineering happens, could open up a whole new arena for pharmaceutical development, defense, manufacturing, all of these things. And then I start to understand the amount of busyness and traffic within low Earth orbit, and the movies like Gravity. You start to get worried and start to think, well, that's a complex area. Maybe we could just start off with, like, what actually is low Earth orbit? And what's happening right now?
Yeah. So the low Earth orbit is, as the name says, is the closest orbit that we have around Earth. And it's the closest one where, for example, we've had the International Space Stations for the past decades. And it's the first one where most of the satellites and all the systems that have been used have been operating. And then after that, you have the MEO, you have here, and then you have the geostationary orbit. Geostationary orbit is where we have telecommunication spacecraft, for example. So it's very interesting what's happening right now because, again, having more private players and having our own systems or critical infrastructure on ground being a lot more dependent on what's happening on the low Earth orbit, this has completely changed the game in a way that there is now space traffic management, pretty much like with flights that you have air traffic management, to the point that obviously you have to understand collision avoidance, because one satellite could be on the same place where you're just injecting yourself on the same orbit, or it's incredible what's happening there, especially if you think about all the Starlinks that we have or the other constellation for SAR imaging, so imaging of Earth. It's becoming a lot more complex, and it is, in fact, there is something which is called the Kessler syndrome, which is a bit of like, panic station situation where a tiny piece of debris is going to create this kind of domino effect of now everything is just going to impact everything else on the orbit, and this orbit is just going to become a huge mess of junk. So that's one of the it's one of those theories that has been going on for some time, where people think it could be a possibility, and what do we do about this? Because if you think about how space was used in the past as becoming more developed after the World War II, so it's always been government and defense and big primes or agencies. Now all these private actors are working in it. There is opportunity for anything. We want to have in-space manufacturing. We want to have space settlements. We want to have people actually living in space. We want to be able to have an entire sustainable circular economy in space where you manufacture, you test, you rebuild. This is something that was never thought about it before. And we don't yet know the impact of having so much happening on the same orbit it's going to have in the future. So this is, in a way, I used to say, or like all of us in the space industry say, it's a bit of a Wild West, because just now we're trying to understand, we need, some regulations. Maybe we need some deorbiting regulations here. We need space traffic management. We need to understand the environment and how these impacts maneuvering. And then there is an extra layer on this one, which is defense. Now, it was never meant for space or the space industry to be weaponized ground. But this is where literally the war is moving. Because if you think about ground operations and how, again, Starlink has been used in war in Ukraine, you think that you can actually control and move the pieces of these puzzles from space. And this is, it's not classified news. In fact, it's been very recently, the US Space Command, the UK Space Command, the Minister of Defense from Germany, Pistorius, they've been very vocal and public about, we're being jammed, we're being kind of chased by an hostile actor in space. Our defense asset and national security may be at risk. So it went from we've gone to the moon and humanity has seen Earth from the moon and this extremely spiritual awakening moment to actually now humanity depends for our own safety on what is happening in space. And this is what's happening on the low Earth orbit already.
Well, when we think about, though, terrestrial air traffic control, we have, inter-country, continental, we have a global set of standards, I would assume, that we all hang off because, we know aeroplanes traverse geopolitical boundaries. There is a whole set of international regulations, standards, bodies who articulate and manage that. Low Earth orbit seems to be becoming, the most valuable real estate that we've ever seen.
Yeah.
Where is the level of maturity in terms of international regulation and standards for low Earth orbit compared to terrestrial air traffic?
We are not there at all. We're definitely not there. In fact, there are two examples that I can give. So there are two companies which I know about. So one is in the UK, Spaceforge, that is founded by a good friend of mine, Josh Western. And another one is Varda Space. So they have re-entry capsules for in-space manufacturing. Varda Space was stranded on orbit because they couldn't get the actual approval from the FAA to come back to Earth. So that's one. And Space Forge had to wait, I don't know how many years into the business to get the approval to actually sending these capsules to space and then eventually come back. So it's the regulations it's really long. Again, because it wasn't needed. If you think about re-entry capsules, besides the shuttle at the time, which was obviously managed by NASA, and these different very long-term missions to Mars or the Voyager, so that these huge, long scientific shots where you have a lander and then the shuttle was the only one coming back, really. Now you can have commercial re-entry capsules. And this is something that was never done before. How do you even consider all these re-entry capsules coming back into the ocean, and how many of them are going to come at the same time? Are they going to, cross each other? Who is responsible for what if something happens in another country that's different from the country of origin of the business? These are all questions that we actually don't have fully an answer to. Even I was at some NATO unclassified events a couple of weeks ago. And one of my questions was, for example, if we detect a space dots, let's say we are detecting a hostile actor which is doing malicious whatever to national security assets from the UK. So we detect this information, and then this information is given to the right people, downloaded, whatever. What happens next? And if we were able to detect a non-kinetic attack, now let's imagine that you were also able to have a technology on board that could have an action once you have detected something. Is that my responsibility? Am I, as an individual founder of a business who has detected something happening in space, be responsible of escalating international conflict because I've detected something and then I've actioned something?
What's a non-kinetic attack?
Like jamming, spoofing, or what we used to say, anomalies or attacks.
So like electromagnetic.
Exactly. Electromagnetic warfare, electromagnetic interference, radio frequency, degradation.
Up there at the moment, what does spacecraft, what are they facing in low Earth orbit? I mean, is there a risk they're going to be hit by junk? I sent you a link the other day about, it was a commercial airliner hit by something falling out of space.
Yeah.
Like, what are the actual risks? So obviously you have malicious intent, which seems to be one of the elements that you're discussing, whether that's kinetic or non-kinetic. Look at me, like I'm straight into the kinetic, and
it is.
But also there's accidents, there's crowdedness, there's people putting stuff up, people that lack of collaborative communication. What's the reality of the environment up there right now?
It's really messy. So if you think about what I used to say, space dots detects and attributes hidden threats. These are the ones. So hidden threats, they could come from space weather events, especially radiation, because radiation is one of the main harshest elements that you can face on orbit. On a low Earth orbit, we also have atomic oxygen, which is something that you don't have on other orbits. And atomic oxygen really eats away life and performance from your systems, from the paints or the coatings that you use for thermal control systems. So there are threats which are by default present because of the harsh environment of space. The ones that could mimic space weather, which are the non-kinetic ones. And then there are the kinetic attacks, like laser dazzling, chasing, or actually attacking a satellite. And then there is debris. So there is the macro debris, there is the micro debris. So very, very tiny. We are talking about centimeters tiny pieces that have been left now behind on orbit. And that is an actual risk.
How fast are they traveling?
A lot. Very fast.
So if you get hit by a screw, is that just going to go straight through things?
Yeah. It's gonna, if a solar panel gets hit by something that is a couple of centimeters, even a couple of millimeters, it's going to be completely broken.
do we have to go through a phase of cleaning up? Do we need to build big devices that harvest this debris that are going to float around chewing up rubbish? I mean, what's the reality of getting back in control of this stuff?
I think it's a bit difficult. There have been lots of concepts about the debris in space. I think it's really complex to be able to clean it up, like clean up the oceans from plastics. That could be maybe the most relatable, comparable metaphor here. You're never going to get rid of plastics from the oceans, really. It's always going to be there. It's pretty much the same on the low Earth orbit. There have been lots of concepts of, grabbing things and removing them. One concept that I love the most is the recycling of this junk from space. So also because most of I'd say 90% of anything that goes to space is made out of aluminium so far. There aren't super, advanced materials besides, again, solar panels or some thermal control systems or some ceramics or anything else. But generally, it's aluminium. So there are companies who are thinking about using these debris, these extra scrap pieces, fusing them, and then 3D print new components in space, especially if you think about having commercial space stations where you actually want to have that circular economy in space. I love the concept because it's pretty much something that we do on Earth. You get plastics from, whatever, and then you recycle it, and then you make it into a new item. This is one of the concepts that I really like.
Is everything in low Earth orbit in a sustainable space, or are all low Earth orbits degrading back to Earth? Like, does everything eventually burn back up, or does it keep circling? How does it keep the energy to keep going?
It just goes.
So it never falls back in. Some of it falls back in.
When it falls back in, because you're losing that escape velocity, let's say, or when you have to deorbit satellites, and this happens also to the Starlink satellites, unless you are deorbiting properly. But then the reason why you choose certain materials to make your spacecraft is because they have to be demisable. So in the moment they cross the atmosphere, they have to fully burn up. This doesn't always happen, though, because some systems are really big and not all of those materials will be able to burn up. In fact, one of the projects or one of the possibilities that we've been looking with Airbus Defence and Space, my previous colleagues at Airbus Defence and Space, is to really understand how certain space environments, especially in the low Earth orbit, affects the use of biomaterials. Because certain biomaterials have certain properties that could be well used for spacecraft or radiators panels, and they will burn up a lot faster in the atmosphere once you have deorbited a spacecraft. So generally that is pretty much what happens right now, but that doesn't tell that if an entire spacecraft has fallen down because of a space weather event, that all of it is going to be burned out. Like if you get it out of control, you're going to have some pieces falling here and there. And that has happened multiple times, especially over this year.
What's clear to me is that space is an unknown, but it's seen as a huge opportunity. Low Earth orbit, that first step into sustainable orbit in space, is being seen as phenomenally valuable real estate for a multitude of applications. But the reality is it's really inhospitable. It's inhospitable for us. It's inhospitable for machines. Like, what are you actually doing to make it slightly more hospitable at space dots? Because we must have a load of data about this environment that we probably haven't processed, that probably isn't connected. Is there like a data exercise to start with where we just understand the as-is environment, how it's evolving?
That's exactly the point.
What does it look like for space dots now what value are you bringing?
Yeah, that is exactly the point.
Because it's so exciting to get lost in the future of it.
Yeah. And it's and none of this future can happen, by the way, if we don't understand the environments well. One of the main frustrations that I've had in my 15 years of experience in the industry is exactly not understanding fully these environments of space and how they impact everything that we do in space, from the selections of the smallest components to, for example, if you think about, thermal control solutions for spacecraft, most of them are completely passive. What I mean by passive, in space, you don't have air. So there is no fluid dynamics. So the only two modes of thermal control are conduction, so touching one another, one piece to the other one, or radiation, which is radiating, pieces radiating, basically. Those are the two simple modes of thermal exchange or thermal control in space. So most of the thermal solutions that you would choose for a spacecraft are passive, not active. And some of them are just really a clever use of paints or coatings or different colors that they have different thermal optical properties. Now, these properties depend on the environment of space. If you don't know the environment of space, by default, you don't know how to properly choose certain solutions. The radiation impacts the electronics that you are using on your spacecraft. The spacecraft is pretty much made out of electronics and chips. So most of these components have to be qualified for the radiative environment. But then the new space industry is going in a different direction where they're using commercial off-the-shelf. So components that don't have any qualification to radiation, the environment, and you use them and you hope for the best. And then you realize, actually, they haven't really sustained the lifetime that they were supposed to sustain. They failed. And then again, they remain as junk in the space environment. So the idea of space dots is to really remove this problem at the very, very beginning, because there are these two very different approaches. Either you are a legacy business who has to be extremely conservative and you are over-engineering, over-designing, using extremely huge redundancy on your system to make sure that no matter what, worst case scenario, you're going to work out. And then the new space industry, which doesn't have the same budget or time of a legacy business, that is like, it's going to be fine. And it never is, really. So there has to be a middle ground, and we want to be that middle ground. So the more we gather data, actual in-space data from the environment, the more we're able also to train forecasting models. Because all the models that right now we have about the space weather, of course, they are relying on historical data, data that has been collected by the agencies with probes that are looking at the sun specifically. But again, they're, not many, they're very expensive, they're not looking at the actual context around the satellite and, the environment in which they are. Or we have radio telescopes or ground systems that are looking from Earth to space, but no actual small in situ packages that can understand the context around the spacecraft and when they are operating.
Well, I was quite shocked by, I was looking at some of the data on, accidents and things that happen. 90% we don't know why. We can see the impact, but don't know why. And then I think I was reading some of your research, and it was down to, the compressive nature of the paint on something, or, its ability to be scraped and whether it retains or moves to debris. The actually, there was an element of a butterfly effect in space that big problems can start with something so, seemingly irrelevant. And then, that creates a resonance of failure.
Yeah.
And it's very difficult to stop that resonance of failure when you're in such an inhospitable environment.
Yeah. For example, we're still in November. So this month, we've seen an extreme, excessive solar activity. Because we are actually in a solar maximum year. So there have been loads of solar storms. Actually, there was one storm called the Cannibal Storm, which is devouring another storm that's happening. It was insane what was happening in space. And again, the data has been collected, but it's definitely not enough. And also, it's also not enough to, let's say, being fear-mongering and saying, oh my God, we have all these space weather storms and life as we know it in space and on Earth is gonna finish. We have to be prepared for the eventuality in which, there is another storm like this one, and what is happening to my operations, what is happening to my spacecraft. Because when this happens in space, your subsystems on a spacecraft, especially the thermal control solar panels, they are going to see a degradation of the material itself, which is probably 300x what they would see in their lifetime. Which meaning the beginning of life and the end of life of these satellites, the way they were forecasted and the performance that were forecasted, beginning of life, end of life, are completely going to be different. And you don't know when your satellite is going to probably, stop functioning just because it's gone under extreme sensitivity during these solar storms. So we want to prevent that. We want to be able to help the entire industry really having a full understanding of what is happening out there and how you can properly start from the very beginning, from the design phase. How can you properly choose materials, components that you can put on your satellite instead of extreme over-engineer or extreme under-engineer because you're under budget and under time.
So it sounds like you're trying to get a really good understanding of the environmental factors of space to be able to guide manufacturing and design.
Yeah.
Is that what SpaceDots is?
Yes. And then there is also the operations factor. Because once you are there, so the idea again is then moving on to the attribution of certain anomalies or certain failures that you may have in space and what you do about them. So that's the long-term vision, being able to attribute this level of, was it an anomaly? Was it an attack? How much do we have to care about certain things that we are seeing happening in space? Was this RF degradation really due to an event? Was this electromagnetic interference really something that I should care about and escalate, or was this just because there was a glitch in the system? So that's really the operational effect on the spacecraft operators. Eventually, the really big vision at the end of the day is to be able to create intelligence grid from space, where we don't even have to rely on having a SaaS platform where you have to wait for this data coming from the spacecraft, downlink, big latency, being turned into the fusion and aggregation of all the other data sets, having your own algorithms, and then giving you the response on what you do. But being able to have these different nodes, that we call them data dots, placed on everything that is in space and being able to communicate with each other. So having edge computing and filtering the real important information from the data that we're detecting, or even aggregating telemetry from the other spacecraft, and then being able to use this AI warning system directly from space. So this is the ideal, or where we want to get, instead of providing, this information with latency and with, days or even weekends until you can have an action, because that's going to be too late.
So is artificial intelligence, machine learning, basically enabling real-time data processing? Like, how are you using AI at SpaceDots now? What's your vision for how?
Yeah, so the idea is to implement some of this, and we're working with another company on this one, with state-of-the-art thermospheric and heliospheric model for exactly this, forecasting and eventually nowcasting. But again, you can have the best model ever, as we know, if you don't have actual data. Even if the data is not extremely accurate, you need to have data to train those models, to pick up on those patterns, and then to be able to say with a lot more accuracy, okay, this is what's going to happen. We are not there yet because the data is missing.
I mean, every science fiction movie seems to have when humans are in space, they have some sort of AI system with them, protecting them, turning against them, in terms of
like
how...
in 2001 Space Odyssey.
So for the last 50 years, there's been a prediction that for humans to exist within space, they are going to have to coexist within some form of cognitive machines. It feels as though that's still solidly science fiction right now, but we're using AI to use data to be more predictive and make decisions quicker. Would that be a sense of where we are now?
Yeah. If we think about machine learning and AI, it's, let's say, ChatGPT. The more data you get in, the better responses you get. Crap data in, crap output. So we are at the stage in the space industry where, sure, we can have forecasting, we can have amazing models, but at the end of the day, it's not as easy as users giving their inputs or their knowledge into a ChatGPT. It's data that needs to come from orbit. That doesn't come easily, and it's not cheap either. So that's the change that needs to happen.
What are you most excited about over the next 10 years? We can see, I think there's programs looking to put permanent infrastructure on lunar infrastructure on the moon. We know there's almost like an international race on the moon. We can see services being implemented in low Earth orbit. Arbeit, it's a complex crowded environment, and SpaceDots is enabling better manufacturing, better data, environmental awareness. What are you motivated by? What's the world going to look like in 10 years if you continue on your growth journey?
I love to think that, and this is also like a shout out to my friends and all the people who are building at the same time as me. And most of them are in space manufacturing or bio or commercial space stations or whatever. I love to see us as being successful in what we're doing and actually being this, space industry, the new space industry 3.0. There was the old space industry or the old space, then there was new space coming with SpaceX. I love for us to be the ones that have built another wave of the space industry, and all these things that we've actually discussed about actually being done, actually being operational, and also making money, because that's one of the very difficult part of space is becoming a profitable business. SpaceX didn't become profitable until decades later, for example, and until we will be able to become as profitable as all the other businesses that we know on Earth as part of the infrastructure. We can dream about space and we can still push the boundaries for space, but eventually now it's just an R&D park. That's what we're doing. It's really an embryonic stage in which we are all trying our best to make something work. And it needs to become sustainable until we can have the first, let's say, settlements of humans in space, which I love to see. I love to go.
Would you?
Yeah, I definitely
would you take the opportunity now to go into low Earth orbit?
Yes. If someone was coming to me and saying, look, we're going to send you there for 3 minutes, if Jeff Bezos wants to call me up, I'm going.
Are you not frightened by the vastness and emptiness and seemingly infinite void that is space?
I thought sometimes what it would feel like to actually be in these tiny capsules and being, again, is this crazy darkness out there and seeing Earth from space. And I couldn't tell until actually this happens. There is a beautiful book called The Overview Effect by Frank White. And it's a collection of all these views, let's say the experience of all the astronauts, majority of the astronauts which have gone to space, and what they felt when they have seen Earth from space. And most of them say it's a spiritual awakening. It's extremely emotional because you realize how tiny and fragile it is, the pale blue dot. And why are we so stupid on Earth when we think we are all so different and we're having conflicts with each other, when we have something that is tiny in the vastness of space and we're all the same. So it's something that really changes our perspective. So I think I would want to go to space to really have that experience, probably cry.
It feels as though you're living that experience already.
Yeah, I hope so. Yeah.
Is there many people see news articles on near-Earth orbit, near-Earth asteroids, things hitting the planet? Obviously, when we look back at key points in time, the dinosaurs, 65 million years ago, was it Cretaceous, Jurassic boundary, KT boundary? These were mega events where there was an impact on the planet. You look at the moon, you can see the craters, that thing's being hit quite a lot. What's the reality or likelihood of the Earth being hit and us feeling some sort of dramatic global changing event?
I don't think it's as dramatic as we would think. It's a possibility, which is there. And it's monitored. It's been monitored since we had the capacity to monitor certain events. And so far, everything is okay. Also because there is one thing that actually not many people know, because why would they? So we have to thank Jupiter. That is pretty much, which is like the biggest gaseous planet we have in our solar system, which is actually protecting Earth from the biggest rocks that could potentially come into our orbit. So Jupiter is pretty much like carrying them towards its pull.
Because of its gravitational effect. So anything coming into our galaxy has kind of got to get through Jupiter's orbit, and that's such a significant body.
Jupiter is pretty much our protector, which probably makes me think why Zeus was the god coming from Jupiter, in a way.
Wow.
I'm just making this, this up, but I think it's probably coming from there.
Tell me, as we draw to a close, I usually ask people whether AI will take us to a utopia or a dystopia. I'm going to change that today, I think. It's clear to me that you have a phenomenal academic depth and a passion for this, that when those two things come together, amazing things are going to happen. So I'm very excited to have spoken to you and be speaking to you today and watch what happens on your journey. I guess for me, there's this huge unknown, but also a exciting pioneering optimism. Because if you're optimistic, an unknown is an opportunity, not a risk, not a liability. And I think that, where we sit now, what's happening, the work that you're doing, the work that SpaceX and other countries are doing is taking humanity, it's opening up a potential new chapter. Let me ask you, Bianca, do you believe space travel, habiting other planets, low Earth orbit, do you think they will take humanity to a utopia or a dystopia?
It is a great question. Also, if you think about all the movies that we've seen, the sci-fi movies, it could go either way. I'm an optimist by default. So I never want to think about the dystopian part of technology. Although it's something that you don't have, what I generally would say is that considering history and how certain things have gone, for example, the word colonizing, we've seen how it's gone in our past. So if we're thinking of moving humanity to another planet by using a certain narrative, that for me is what would probably make it dystopian. It's the narrative and it's the messaging around what we're doing with technology. But if you change that narrative and make it relatable to what has happened to us in the past and remove those negative connotations, but if we are leaving this into the hands of a few people, then the entire humanity will have to, in a way, accept the consequences of that design. This is what scares me the most. And that's the reason why I'm very passionate about the diversity of thinking. And it's not just gender, it's diversity of opinions. We don't need just engineers. We need philosophers, we need artists, we need musicians, we need a lot more people to think properly about what the technologists are doing. Because engineers think about something that needs to function efficiently. They don't really think about the poetry of it. But we need the poets, we need the philosophy, we need to understand the ethical implications of what we're doing. And if all of us, will be able to do this together, then it will be an amazing future.
We are in a computer game.